Hello and welcome to the second in my series of videos on ARM Cortex-M4 microcontroller development with the STM32F4 series. My name is Sam Walsh from the School of Electronics at the University of Manchester, and in this video I said I was going to go through the code from the last video, the blinky LED project, but I think that code's kind of a bad example to go through. It's kind of very generalized and not board specific, and a lot of the code's kind of overcomplicated in it for no reason. So I think what I'm going to do is, in this video I'm just going to teach you how to set up a Keil project from scratch, and then in the next video I'm going to start to build up a bit of the code that's in that Blinky project so you understand it a little bit better. Right, okay, so we're in Keil right now, and I'm just going to take you through setting up a basic project. So you want to click project, then new Microvision project. Save it somewhere. I'll just call it test project. There's already one there. So save. Yes. Then hopefully you should see ARM and ST microelectronics there, because we installed the software packs for those. If you don't see those there, then go back to the first video and install the software packs. Right. So we want to select STM microelectronics, then STM32F4 series, then the F401 series, and finally the F401RE, because that's the chip on our board. Okay, click OK. So this is where you can choose to add software packs to your project. So there's a few different board support packages. See, if you see Nucleo F401 there and expand these, you can see it gives you an API for the buttons on the board. There's two buttons on the board, and also it gives you an API for the LEDs. We're not going to be using either of those in this project, so I'm just going to do a basic main file. But if you did want to add those there, then you just click select, and it'll add them to the project. And you can find more about those if you click those links. What we do want to add is the Schematics core. Schematics is an ARM abstraction library that's common among all of ARM's processors. Really, you can read about it, but you just want to include it. It just comes with loads of standard routines for very just ARM specific things. So every time you make a project, really, you just want to include the core Schematics library. Right, what else do we want to do? We want to click device, and we want to add the startup code for our device. You can start these up manually and with all the assembler language, and you can find out about that in many books, but it's much easier to just click OK, and that adds the startup code for you. And I think that is it for now. Yeah, we just want the Schematics core and we want the device startup. Okay, so click OK. Right. And yeah, if you click expand there, you should see we've got the device startup code, which we can have a look through. It's an assembler file and a C file as well. But again, all this does is make sure that your processor boots into main on your source file. You can basically just always add them and not really worry about it. Right, so from here we want to add a source file. So if we right click and if we just click file and new, it'll create a file, and then file save as, and I'll just call it source. Let's see. Okay, and it's not been added to the project yet, so we have to click right click on source group and add new item to source group 1. Oh no, sorry, add existing item to source group 1, and we should find that source file I just made then, source.c. There we go. Right, there's nothing in it at the minute, so I'm just going to put some basic C code in here. Include SDIO.h. I think we have to do int return on a main. There we go. So I mean, it doesn't get any more basic than that. And I'm just going to Control S to save this. So that's the source file that we're going to be flashing into this microcontroller. Now, the first thing we want to do is create a target. So we've got a target called target1, but I think we should really rename that. So if you click project, then manage, and project items, you can see we've got a target there, and you can change the names of like the source groups here as well. So I'm going to call my target STM32F401 array nucleo, and just for fun I'll call source files. Okay, so if you created more targets, when you click this drop down button here, they'd all show up. Right, so that one's created. Now we need to set up some options for this board. So if you click on the little wand there, this will take you to setting up the project. So the first question it asks you is, what is the crystal frequency? And to find this answer, we need to go and find out what crystal is actually running on the board. Now, there's a picture of the board, and if you look, you might see on yours that X3, which is a crystal, is not fitted. So it looked to me as if there was no crystal on the board, but let's investigate and find out what kind of crystal there is. So if we go to STM32F401 nucleo, and this page on ST's website, that takes us here, and if we go to design resources, we can find the Altium schematic pack. The schematics are also in the user manual, which I'll hopefully show you now, but while we're at it, I'll just download this schematic pack. Okay, extract. And here we go. They've been very kind and give us pretty much everything. We've got the Altium project here, so I'll open that. Again, yeah, if we just look at the user guide here, if you scroll all the way down to the bottom, it does have all the schematics on there, but I thought it might be easier if we just go through the Altium files together. Right, so there's a few schematics here. Right, and this first one, this MB1136 schematic, shows the ST-Link programmer here, and then because remember we've got two processors on our board, we've got the ST-Link processor, and then the STM32F401 array. Yeah, so if you look here, there's the MCO connects from the ST-Link all the way to the MCO of the STM32F401. Now, if we go on, this is the ST-Link schematic. You can see there's an 8 megahertz crystal right there that goes to OS in and OS out, but there's no net labels. It doesn't seem to connect to that MCO. So where's MCO? It's actually over here, and it comes out of P8 there, and then from MCO, if we go to this one, yeah, we can see that there's an MCO here going into the microcontroller, into oscillator in. So what is MCO? I was wondering that myself. Oh, also while we're here, if you look there, you can see X3, which is that crystal that's not fitted. So if you did want to not use this MCO, you're going to have to break that solder bridge 50, and you're also going to have to install a crystal here, and then change, obviously, your oscillator settings. But let's find out what this MCO is, because that's the default option. As you can see, this is all not applicable, not applicable, not applicable. It's because they're not fitted in the board. Right, so where do we find out what the MCO is? We're going to have to go to the actual processor page, not the board page. STM32, oops, F401 array. Yep, and if you look, we've been going to this Nucleo page, which is the board page, but then they've actually just got a page just for the processor, which is here. And this design resources here contains tons of information about the processor. The main one we want right now is down here, the reference manual, which is like the Bible really of that processor. So this is the reference manual, all 841 pages of it. and pretty much everything you could possibly need about the processors in here. How to use DMA, how to use the GPIO, clock registers, all that kind of stuff. But what we're interested in is MCO, so I'm just going to do a search for MCO. And it tells you here that microcontroller has 2 clock output pins available, MCO1 and MCO2. And so it's the clock output. So on this schematic here, ST-Link, it's taking in that 8 megahertz crystal into its oscillator in, and then it's outputting just the 8 megahertz signal on this MCO, which is then used by the STM32F4 through here in its oscillator in. So we've got an 8 megahertz crystal shared among 2 processors, which is kind of a neat feature. So anyway, that's enough of a ramble about what the processor is, but we've figured. So let's go back into Keil, and we want to set the crystal to be 8 megahertz. Now you can change these depending on what kind of vectors you want and where you want the code to read and write to, but for now I'm just going to leave them to the default values, and we're going to go to debug and settings, and you need to select the ST-Link debugger there and click settings, and it'll probably say unknown target connected. That's because the protocol that is used to connect the debugger, JTAG, it's got a stripped down version which doesn't use as many pins called SWD. So the way that the ST one connects is through SWD. Now you can get JTAG programmers standalone ones for this board, but for now we're just going to be using the onboard one, which is the SWD one, and you should see it change here, which is detecting the actual the actual processor. So we want to leave these, and you just want to make sure there that you've got flash, 512 kilobytes flash. Now if you don't, you need to click add, and then your options should be here. But we want that one, the 512 kilobyte one, because that's the processor we've got. And you can make it run after resetting, but we're just gonna not do that. Is that everything? Yeah, I think that's everything that should make it work now. So let's press OK. Oops, I'm getting my emails there. I'll close that. Right, so let's try and build this really complicated source project. Let's give us one warning. The warning is probably file ends without a new line. Right, okay, it doesn't matter. And then hopefully we'll just click load, and it should load it to the board. And yep, flash load finished. So that means that we had everything set up properly. If we had these options wrong, so if I click, say, that debugger and OK, it should say it can't load to the board, or there, no debug unit found. Yep. So that kind of proves that we had it set up right. I think also if we didn't have this set, it also wouldn't load onto the board. Yep, flash download failed. So hopefully this video covers everything you need to set up a project of your own. In the next one, I'll hopefully show you some basics of coding. Alright, thanks. Bye.